Okay, 3, 4 exponential and logarithmic equations. You've done everything we're going to do, and we're just going to do it more. We're just going to solve them. So, one-to-one property, we need to remember if the bases are equal, the exponents are equal. On logarithmic, if the bases are equal, the x and the y are equal, right? Inverse property, we need to be able to change it from exponent to logarithm, logarithm to exponent. We need to remember that if I have a to the log base a, the answer is x. If I have log base a of a to the x, the answer is x. Okay, those are all things we need to remember why we're doing this. Okay, so first thing we're going to do is we have 2 to the x equals 32. How would you solve that?
Make 32 a power of 2.
Make 32 a power of 2 so we can use the one-to-one property, right? So 2 to the x equals 2 to the 5th. It's one you probably should know. And so x equals 5, and that's the one-to-one. Okay, on B, we have natural log of x equals natural log of 3. Is there any rewriting to do?
No.
Nope. X equals 3. And that's the one-to-one again. Now, I could rewrite it. I could make it e to the natural log of x equal to e to the natural log of 3. Because if I do it to one side, I have to do it to the other, yes. And the answer would still be x equals 3. That would be completely ridiculous to do that. But is it possible to do it? Yes. Okay. 1/3 to the x equals 9.
Make 9 a power of 1/3.
Okay. We can. So be 1/3 to the x equaled.
2.
Wouldn't it be negative 2?
That's what I said.
Oh, I didn't hear negative 2. So x equals negative 2. Could I personally would do this. 3 to the negative x equaled 3 to the, not 3. How was I going to do that? Yeah, 3 squared.
Oh.
That's how I would do that. So I would get negative x equaled 2. So x would still equal negative 2. Does it matter how I do it?
No.
No. I could have made this to the negative. I could have made it 9 to the negative 1/2 x equaled 9 to the 1st. Couldn't I have? So then I would get negative 1/2 x equals 1 multiplied by the reciprocal, and I still get negative 2. So are there multiple ways to do this? Whatever your brain sees, that's where you need to go. I like this way. I want to be able to use this way, but my brain gets mixed up sometimes. And I don't know why I want to be able to use that way. I just do. Okay.
What property was that?
Oh, what property was that? That was 1-to-1, wasn't it?
Yeah.
When I did on the second one, the first was 1-to-1, and then it was like inverse and 1-to-1 the way I did it. I'm just trying to show you weird ways we can do it. Okay, so e to the x equals 7. Well, I can't get to the x to solve for it, can I?
Would you? Can you make 7 basically?
Nope. No. What happens when it's in one form and I can't get to an x? What could I do?
Forms.
Could I change forms? Because right now that x is in the domain and I can't get to it, can I? I need it in the range. So I would switch it from exponential to logarithmic. Now there's a couple ways we can do this. There's an e there. The way I like to do it is just say natural log of what?
X.
Mm-mm.
E.
Mm-mm.
E to the X.
7 equals x.
Oh.
Because these two switch places, yes? Okay, I like to do that. And the answer would be, without a calculator, the answer would be x equals the natural log of 7. And that's the inverse property. Okay. Without a calculator, on your test, you are not going to have a calculator. That is how you leave your answer. Okay. Now, if you look at CalcChat or some other places, they will do this. They're going to use the inverse property in a different way. They're going to take the natural log of both sides. So you would have the natural log of e to the x equal the natural log of 7. I can do whatever I want to an equation as long as I do it to what? Both sides. Now, natural log of e to the x is just what?
X.
X. And I still get x equals what? Natural log of 7. So whichever method you want to do, I will tell you, I just switch forms. I think it's easier. I think it's less hassle. Now, there's times I have to just take the natural log of both sides, and there's times I don't have to take it. If you're good at changing from logarithmic to exponential and exponential to logarithmic, just do it. You're still using the inverse property. You're doing it in a different way. Okay? So, natural log of x equals negative 3. So I can't get to that x because it's stuck in the natural log. So how do I get it out of the natural log? I put in exponential. So do you guys want to just switch forms, or do you want to? I'll do it both ways. You tell me what you guys want to do. What's my base?
E.
E, because it's natural log. So e to the
Negative third.
negative third equals x. So my answer is x equals, can't leave it a negative exponent.
E to the third. No. Wait, yeah.
No, close. 1 over e to the third.
Okay.
And this is inverse property again. Now, again, in the textbook, what they would say to do is raise both of them. So they would say e to the natural log of x equaled e to the negative third, which is still x equals e to the negative third.
That's just too much.
To me, it's extra that you don't need to do. Okay, so log of x equals negative 1.
Would it be
Put in an exponential.
10 to the negative 1?
10 to the negative 1 equals x. So x equals
10 to the.
1 over 10.
1 over 10.
Oh. No.
And I'm going to tell you on the test that is the biggest mistake historically over the last 19 years. People tell me this is the answer. People tell me this is the answer. Are those the answers? No.
Is that inverse again?
What?
Is that inverse?
Yeah, they're all inverse. This whole slide's inverse. Spoiler alert. Okay,
Really got me.
Log base 3 of x equals 4.
Three to the 4 equals x.
3 to the 4 equals x. So x equals
81.
81. That was pretty good. Quick. Did you go 3 is 9, 9 is 81? Hopefully. You guys are starting doing that, or just did it?
Just no.
Because you guys have done them so much. Any power of 3, probably up to 5. And powers of 2, quite a ways. You should know, be able to do very quickly. Yes? Questions? Okay. Strategies. These are your strategies. Rewrite the equation in a form that allows you to use the one-to-one property because that is the easiest, yes? If you can't use the one-to-one property, use the inverse property. Exponential to logarithmic or logarithmic to exponential. We're going to do a lot of work, but once you get to the point where you're like, okay, now what? Your now what is switch forms. Got me? Like when there's nothing else to add, subtract, multiply, or divide by, switch forms. Okay. So e to the negative x squared equals e to the negative x minus 4.
Aren't those just equal?
Yep. So negative x squared equals negative x minus 4. I'm assuming that's what you meant by that. Because it's the one-to-one property.
Yeah.
So now what?
Change one.
Nope.
You said now what?
I know.
Factor out negative.
Well, before we even do that, it has to be set equal to 0. So quadratic has to be set equal to 0. Are we adding x squared?
Yeah.
Yeah, then we don't have to factor out a negative, do we? So then we,
Factor? Can we?
can you?
No.
So if you can't factor, you have to use the
Leave it.
quadratic formula. So x equals 1 plus or minus 1 plus 16 over 2. Oh, well, this one's nice because you really don't. Is there anything we can do to any of this? Okay, question for you though. Exponential functions, no, e, yes. Looks like this. What's the domain?
Oh,
All real numbers. So am I good? Am I good?
Yes.
Yes. Okay. So what if I had natural log up here? If I had natural log in my equation, would I be good? No, because natural log is greater than 0. So which one of these would not be good? Plus or minus? Because it's plus the square root of 17 and minus the square root of 17, right? So which one would be bad?
minus.
Minus. So you would have to identify that only 1 plus the square root of 17 over 2 would be your answer. Okay? So do I have to think about my domain when I'm thinking about logarithmic functions? Yes.
Leave it.
Do I have to think about it when I'm thinking exponential? No. But I do with logarithmic. Okay. 3 times 2 to the x equals 42. What should we do first? Olive, what do you think? What's there that hasn't been there before? That 3. So what do I need to do with it first? No, you have to divide it. You can't distribute into an exponent.
To be 42 divided by 3, which is 14.
16.
16, sorry.
Okay, so until the exponent or the logarithm is alone, you can't do anything to it.
Okay.
Okay? Just like if it was a square root.
14.
No, it isn't.
3 goes into 4 one time, and then.
Oh, never mind. I was doing 2. Sorry.
It's okay.
You're right. Thank you for arguing with me.
No problem.
Okay. Now what?
Make them the same base, maybe?
You can.
Switch forms,
Switch forms. Why can't I do same base?
because 2 isn't a power of 14.
14 isn't a power of 2.
Yeah, that's what I said.
Okay. So now this is where we can do a couple different things. When you leave your answer, I want it be left like you can put it in a calculator. So that means change a base formula, yes? Okay. So there's 2 ways we can do this right now. What would be the first way? What would you guys tell me right now? You said change forms, yes? So how would you do that, Alex?
Log base 2 of x
Not of x.
of 14 equals x.
Okay, log base 2 of 14 equals x. So that equals log of 14 over log of 2. Correct? Okay, it's change a base formula. Now, if you go and you look at CalcChat, this is how they're going to tell you to do it. And I am perfectly fine with this. This is all good. I'm happy. Don't think you have to change. What they say to do is to take the natural log of both sides.
Following NHS members are dismissed to go to Collins area to get ready for the coffees and cookies for the Veterans Program. Jane Allington, Ainsley Hughes, Savannah Mason, Riley Swearingen, Olive Savy, Emma Spencer. I need to have one of you please stop at the office.
Let's
before you
finish
go down
this.
there.
Let's finish this one before you go. Okay? Okay, so according to our rules, then what happens to the exponent? It comes where?
Out.
Out front. So I have x natural log of 2 equals the natural log of 14, and then I would divide by the natural log of 2. So x would equal the natural log of 14 over the natural log of 2. And from what we know about the change of base, aren't both of these answers the same?
Yeah.
Do I care which method you use?
No.
No, I do not.
I like the first one better.
I think the first one makes more sense in your guys' brain.
That second one's too much.
Okay, so I'm going to finish. I think I have 2 more examples, so I'll post them.
Okay.
And work on your assignment, but you don't need to finish it this weekend.
Okay.
So, Alex and Sam, when we get done, remind me to change your due date. We got 2 more examples. At least 2. Yeah, we got more. Okay. Natural log of 5 minus the natural log of x equals 0. Have fun, guys.
Get out, would you?
I'm trying.
Okay, so what do you think we have to do here first?
Leave it. I'll take it out. That's
We have 2 natural logs I want. 1? Well, I guess there's a couple things we could do. You guys want to condense, or do you want to move over?
Move over.
Like add natural log over.
Oh. Probably add over.
Add over, okay. Oops. So I have natural log of 5 equals the natural log of x. So x equals, Now, the first thing I was asking you, if you wanted to do, is condense. So we'd have the natural log of 5x equals 0.
But it's.
Oh, wait, it's divided. Sorry. Not multiplied. So the natural log of 5 divided by x equals 0. Yes. So now I'd have to switch forms. So my base is,
E.
so e to the 0 equals 5 over x. What's e to the 0?
1.
So I have 1 equals 5 over x.
Divide x over.
How about multiply it over? So x equals 5.
Too complicated.
Now, there are times, though, you have to do this. Okay? Like, what if that wasn't 0? If this wasn't 0, could I use this method like that? No. Does that make sense? So there's times where you have to do this method. And that's when it's not equal to 0. Okay? And sometimes you're going to have e left in your answer. So 1/5 to the x equals 125. Back to a basic one. So how do you guys want to switch forms around?
Probably log base 1/5 of 125 equals x.
Okay, we
That's
can.
the only way I think of.
Is 125 a power of 5? So couldn't I get same bases? Sam, how do you want to do it?
Oh yeah, never mind.
How do you want to do it? Say that again. You put the negative. So did you go 5 to the negative x equal 5 to the third? No? Okay, tell me what you did. I'll go with 1 over 5 to the negative third. Is that what you said? Or did you say 125 to the negative third? Okay. So, do both of these work? Yes. They both work. So, x equals negative 3, negative x equals 3, but x still equals what? Negative 3. And Alex, yours would have worked. Log base 1/5 of 125 equaled x. But then you still would have had to log to the base 1/5 to the 1/5 to the negative third. So x would have equaled negative 3. I think, though, if you would have done this way, you would have got lost in it. Okay. It works, but you can't get lost in it. You still got to do the...
I looked past the first option.
Okay. Tell me when you're good. Okay. Okay, so e to the x equals 13.
Change of base.
Change of base. So the natural log of 13 equals x.
That's really it.
Okay, yeah, that is it. Natural log of x equals negative 1/8, or negative 8. Keep saying 8. So just switch forms, right? Bases
E.
to the negative 1 to negative 8
Equals
x. Can I leave it like that?
No.
1 over e to the 8th. Let's see how many more examples I have. Okay. Okay. So e to the x plus 5 equals 60.
Minus 5 over.
Minus 5 over. So e to the x equals 55.
Change base.
Okay. So what do I get?
Natural log of 55
Equals x. And actually what you're doing is changing form, not base. But I knew what you meant. Okay. Log base 3 of 5x minus 1 equals log base 3 of x plus 7.
Probably change form of both sides.
Or isn't it just 1 to 1?
Oh,
Because log base 3.
yeah.
So just 5x minus 1 equals x plus 7. So what? 4x equals 8 and x equals 2. Now this, we're going to stop after this one. We'll do the others on Monday. What happened if that was a negative 2? Would we have a problem?
Yeah.
Because the log is like this, yes? So if that was negative 2, actually not that. If this 2 makes either of these negative, is it no solution?
Yeah.
Yes. Does it make either of those negative? No. So we're good. So with logarithms, check and make sure your answer isn't making it negative at the beginning. Okay?